Hello, my name is Petty Officer Adam Glover, and welcome to today's presentation. So let me tell you a little bit about myself. I've been in the Navy for 16 years, and my job in the Navy is operating nuclear reactors on submarines. I spent 2 years in Charleston, South Carolina to learn how to do this. I studied everything from calculus, physics, thermodynamics, metallurgy, radiobiology, mechanical engineering, electrical engineering, and of course, nuclear engineering. During my 16 years in the Navy, I've worked on 2 different submarines, the USS Jefferson City out of San Diego, California, and the USS Hartford out of Groton, Connecticut. In between those times, I was actually an instructor teaching nuclear power back in South Carolina. In 2011, I even taught the first group of female submariners. Since I've been in the Navy, I've actually been able to travel all over the world, everywhere from Japan to Singapore, Norway to Scotland, and even the North Pole. So, why are you watching this today? What is the point? The point is to learn about nuclear power.
Nuclear. It's pronounced nuclear.
Whatever.
So today, we're going to talk about fission, energy production, how we control nuclear reactors, how we actually utilize the energy that's produced by the reactors, as well as talk about radiation and how much you are actually exposed to. So to start off with, we need a fuel source. And the fuel source we're going to use is uranium, specifically the isotope uranium-235. Now, uranium-235, big strong element, has a lot of energy in it. So we need to get to that energy. And in order to get that energy, we need something to break that atom apart. Now, the thing we're going to use is a neutron. It's going to go in, it's going to hit the nucleus of the uranium atom, super excited, and then it's going to cause it to blow up. Why? Because the best things in science blow up. Now, the blowing up of this atom is called fission. And fission releases a couple of different things. The first thing it releases are fission products. These are smaller, lighter elements. For the purpose of our conversation, they really don't matter. The second thing that gets released is more neutrons, about 3 for every fission if you do the math. Now these neutrons go out, they find other uranium atoms, and they continue the fission process. This process combined is called a sustained chain reaction. Now to control that chain reaction, we need a way to control the amount of fissions that happen. In order to do that, we use a thing called control rods. Now control rods are made of an element called hafnium. And hafnium has a really cool ability. Hafnium has the ability to absorb neutrons and stay stable. So by using control rods made of hafnium, we actually control how many fissions happen, and by that way control the amount of power that is produced by the nuclear reactor. Now besides fission products and more neutrons, we actually produce a third thing from these fissions. That is energy. And this energy is actually released in the form of heat. So I need to put something in the reactor in order to absorb that heat. Now, as the water absorbs the heat, it eventually is going to want to boil, which is at 212 degrees Fahrenheit or 100 degrees Celsius at 1 atmospheric pressure or sea level.
Boil water? What am I, a chemist?
Now, the disadvantage to having the water boil is that I can no longer absorb thermal energy once the water turns from a liquid to a gas. In order to prevent it from boiling, what I have to do is I have to raise the pressure. As you might remember, water boils at 212 degrees Fahrenheit or 100 degrees Celsius at sea level. So by raising the pressure of the system, I in turn raise the boiling point. Let's put it together. This here is an actual reactor plant. The reactor plant consists of a couple of major parts. First off is the reactor, which holds the uranium-235 as well as the control rods to generate power. Above it is the pressurizer. The pressurizer is what pressurizes the reactor plant to prevent the water from boiling so it can absorb more thermal energy. The bottom part with the main coolant pump actually pumps the water through the reactor and to the steam generator. Now the purpose of the steam generator is to generate steam. It does that by running primary coolant through the tubes. The tubes are covered with water that absorbs the heat from the primary coolant. That water then boils and is sent out the steam outlet. So from there, it goes to a couple of different places. The first place it goes to is the turbine generator. The purpose of the turbine generator is just to generate electricity for use by the ships. The turbine generator does this by using the steam to spin the turbine blades on the turbine generator. The turbine blades are attached to the coiled wire cylinder, which in turn spins in a magnetic field. This causes the turbine generator to create electricity. This electricity powers everything on the ship, from pumps to lighting, navigation, and steering systems, to the two most important things on the ship, the coffee maker and the ice cream machine. So the steam also goes to the main engines or the main turbines. This is what actually drives the ship through the water. For a submarine on the surface, that means you can go over 15 knots or about 16 miles an hour. However, once we submerge, we can go over 20 knots or 23 miles per hour. On an aircraft carrier, they can go over 30 knots or 35 miles per hour. This is especially impressive when you consider that they are 1,000 feet long and 12 stories tall. The aircraft carriers even use the steam to launch aircraft. They do it by collecting the steam and causing it to build up pressure. Once enough pressure has been reached and it's time for the plane to launch, they release that pressure through the catapult, which launches the plane forward, going from 0 to almost 200 miles per hour in under 2 seconds, and causes the pilots to feel over 5 Gs of pressure. In other words, if you weigh 150 pounds, it would feel like 750 pounds pushing against you. Once all of that steam is used up, it's sent to the main condenser. The purpose of the main condenser is to turn that steam back into water by exposing it to seawater, which is going to be much colder than the steam itself. Once the steam turns back into water, it is sent back to the steam generator for reuse. So one of the major fears that people have for nuclear power is radiation. And a lot of it comes from not understanding what radiation is and how much you get exposed to on a daily basis. Radiation is simply the transmission of energy in the form of waves or particles. Nuclear reactors release 3 basic types of radiation: alpha, beta, and beta gamma. Now, alpha and beta are not normally a concern because they have what's called a low penetrating power, or cannot have a very large effect on the human body. So our main concern is with gamma radiation. So a great way to illustrate how much radiation you get is from a banana. Bananas naturally have radiation in them, along the lines of 0.1 microsieverts, or a decimal point followed by 6 zeros, followed by a 1. Now this is a really negligible amount of radiation to receive. However, it's a great way to scale and see how much radiation you get from different things in your life. For example, if you've ever flown on an airplane before, you received radiation from cosmic sources. For a 5-hour flight, you got approximately 5 microsieverts, or the equivalent of 50 bananas worth of radiation. Now, X-rays are essentially just pictures taken with radiation. And if you've ever gotten an X-ray before, you got 80 microsieverts, or the equivalent of 800 bananas worth of radiation from that single X-ray. In contrast, working on a nuclear-powered submarine, even for an entire year, will only get you about 6 microsieverts, or the equivalent of 60 bananas. So how are we doing it? How do we get our radiation exposure that low? There's 3 basic ways we do it. The first is time, or in other words, minimizing the time that we spend near sources of radiation. Combined with time is distance, or maximizing the distance from a source of radiation that a person is. The amount of radiation that you receive goes down exponentially the farther away you get from it. Finally is shielding, or putting something between yourself and the source of radiation to lower your exposure to it. We use mainly lead, steel, and water in the Navy to reduce our radiation exposure. So to review, today we covered nuclear fission, how we produce and control energy in a nuclear reactor, what we do with the energy that is produced by a nuclear reactor, as well as radiation to include the sources of radiation in your everyday life and the steps we take in the Navy to minimize our own radiation exposure. I hope you learned something today. If you want more information about the Navy's nuclear power program, please contact me at the number you see on screen. And as always, follow me on Instagram at EMN1_Glover. Thank you and have a great day.
Jump!